So circling circles, because if you really enjoyed completing the square, which we're going to do a lot in this section, for some of these problems, not only do you get to do it once, you get to do it twice. Double the fun, double mint gum, all right? Circles have this standard form right here, x minus h squared plus y minus k squared equals r squared. Now we're using h and k kind of like we did with vertexes. But now the h and k, if you were to put these in an ordered pair, such as this, h and k, once you know those values, that is actually in the circle. This is the center. Okay, so before with a parabola, h and k is the vertex. With a circle, it's the center. Now, you may not be so familiar with circles, so I'm just going to go over this real quick. But in a circle, yeah, they're quite round.
I know they're quite round.
And the middle of the circle, which is showing right there as h and k, is what we call the center. Now again, it's just because not everyone deals with circles every day. I'm trying not to be facetious about that. It's actually called the center. The only other part that we really need to be aware of is the radius, which is it's the same distance from the center to the edge of the circle anywhere. So I'm showing it right here, but if you went from the center to this edge of the circle, it would still be the radius. Or if you went to this edge of the circle, it'd still be the radius, or this one, or this one, or this one. There's an infinite number of radiuses that we could show here. Now, there is another value, though, that is related to the radius, and that is the value that stretches from one end of the circle to the other end of the circle, but it has to go through the center. I've made this purple. This is what we call diameter. I'm pointing this out just because I'm not sure that I remember seeing this. The diameter, you can see, since it stretches from one end of the circle through the center to the other end, is double the radius. Or you could look at the radius. If for some reason you have the diameter, the radius is half the diameter because it only goes from the center to the edge of the circle. So I'm pointing out the diameter, not really remembering if we're going to see any, but it's possible you could even in the future. For the most part today, we're just looking at the radius. Now, the radius is shown in this standard form up here. R is for radius squared. Now, this means that if this value, let's say, was 25, if I wanted to find the radius, I would square root this value to find the actual radius, because if it was just showing 25 right here, that would be the radius squared. But I just want the radius for these equations and for the information that it's going to be asking for. If by chance we end up with something that's kind of like in a standard quadratic form, it's possible that we may need some completing the square, not just once, but twice. Once for the x's and then once for the y's. Now, since it's an equation, though, for me, when I complete the square, right, because I've got to take a value and maybe add it in here to make this a perfect square trinomial, then I would have to add it to the other side, right, because I'm now looking at it as a principle of equality. And that's hopefully it kind of became obvious that we're going to use completing the square because it's an x minus h squared business, right? So we're looking at taking perfect square trinomials and then forming them into this with the x's, but then there's going to be y's mixed up into the equation as well, and then we got to complete the square with those as well to make a perfect square trinomial, which then gives us this square binomial there. If that doesn't make sense, which I hope it does because we've seen a lot of this, if it doesn't though, we'll see it in examples. Circles are so important that one of the greatest mathematicians of all time, top 3 they consider him, he died because of circles. So he's sitting in his apartment, we'll call it. Maybe it was a villa.
Who was it?
So this guy is sitting in there and he's drawing circles, right? Unfortunately, his city is being taken over, I believe, by the Romans because he's Greek. And he's sitting and he's so passionate about circles that, by the way, he was so good at math that, again, I think it was the Romans. But they were like, hey, if you see this guy, spare him because we'd like him to work for us. or we'll torture him until he does. And so, but they walk in and they're like, hey, you're coming with us. And he says, screw you, leave me alone, I am drawing circles. And so they gave him a nice sword in the back. They didn't like how he's talking to him, so they killed him. And that was Archimedes. So, there's more stories about him, which is kind of funny. I guess when you're a math nerd like that, that's what you do, but whatever. Well, this one's great. We just need to draw the circle with the center at 1, -2, with a radius of 3. So again, this is more like, do you understand the vocabulary, right? So the center, which we saw was H and K, I don't really care about that right now, I'm just reviewing it. But I can find my radius, my center, at 1, -2, so from the origin to the right one, down 2. Right there, that's -1, 2. So I would put the center there, and I think this is the way it works on the assignment. You have to click on the center first, and then some point on the outer edge. It says right here that it's a radius of 3.
-1?
That's better, 1, -2. I had the point in the right place, I just labeled it wrong. It's all good, man. All right, so I got to go 3 in any direction from the center. Now, if I want to do this funky like, I would make it diagonal, but if I can stay on these lines, just 3 in any direction, that would give me the radius. Since I'm doing this by hand, though, I'm going to give myself 4 good values to work with. So I'm going to go first to the left, so that'd be 1, 2, 3, so that this would be the outer edge of the circle. I'm going to go down 1, 2, 3 as well, and then to the right 1, 2, 3 right here, and then up 1, 2, 3. So I can see it kind of gives me these values on the outer edges of the circle, kind of in quadrants, kind of. Okay, but now that I have that, I'm ready to draw it. And since I'm doing this with technology, let's do this better. Bam. I've never drawn a better one in my life. Fortunately, I have technology to use. If I was doing this by hand, which you don't really want to see, I'm still going to show you. I'm better with a pencil. Let's see if I can do this. Something like that. Notice I'm just kind of doing a little bit at a time, Yeah. Now it looks kind of like a fuzzy circle that I've done in orange, but it's doable. It's okay. So this one's saying write the equation of the circle. Oh, okay. If I want the equation of the circle, I need 2 things. I need the center, and then I need the radius. So if we look at this one, again, I'm going to look at this as the diameter. I'll do it horizontally just because I think I'm better that way, but yeah, that's okay. So I see this is my diameter. And I'm using diameter just because I can see it pretty clearly right here. Some of you, I think, may not need the diameter, and if you don't, that's fine as well. But I'm using the diameter just because it's something that we can verify without having to think about where the center is. But now that I have it, I just need to cut that in half. So I see that the diameter is 1, 2, 3, 4 boxes. So the middle one, I'll say boxes, the middle one, the middle mark right there is the center. Let's see if I can do this ordered pair correctly. I believe I see that as -1, -1. Now that's important because that's my H and my K for my equation. In addition to that, I also have my radius because I can go from the center to the outer edge of the circle, which shows that my radius is 2, which is important, okay? So let's go back to the equation. So this is the equation, the standard form equation for a circle, and some of this stuff, like we've seen before, is not going to change, right? So I got x minus h squared plus it should be y minus k squared equals, I'll put the radius squared, and then we'll just kind of evaluate that. Some of you may not have to show that work, but I'm going to show it. Now the h that we found is -1, and instead of showing this as -1 right here, the minus negative, I'm going to simplify that into a plus. But in addition to that, the k also was -1. And I don't want to show minus -1. I'm going to make it one individual operation or sign and make that +1. The last thing I need is the radius, which we found to be 2. And I know that 2 squared is 4. So this means that my full equation would be this one right here at the bottom. And again, this was nice because we were kind of given all the information that we needed with the circle that was given. This is all that we want right there. Now, I know you guys want me to say, well, what about completing the square? We're going to complete the square, right? Because you want to do it so bad. It's coming, just we want to know that if you see a circle, you could write the equation for it, or if they tell you the radius and center, that you can put it on a graph. This one, it's the same exact problem that we just saw. It's just now they've given us the center and the radius. Oh, that's very generous. So let's see what that formula was. Let's see, paste.
Does it get more
Found it.
complicated than that?
Okay, so I'm just filling in the blanks here. And, well, let's write out the stuff that doesn't change, right? So we got x minus squared plus y minus k squared plus, equals, rather, the radius squared. I'll start with the h and k. So the h, the center, is the x value of the center, which is, in this case, just 8. So I can show that as -8. That's good. And then the k value that corresponds with it is its y value in that ordered pair for the center, which is showing as -6. Now, when I show this -6, generally what I would do is I wouldn't even worry about putting the minus negative. I would just change this into plus right there, okay? Then we also have the radius, which is 13, so that would be 13 squared, which I believe is 169, but I'll check on my calculator. Boom, it is, yep. So 169 equals this stuff right here. Yep, so that's it right there. Let's box this in because it looks so pretty. Now we get into the real fun stuff on this. So we got to actually find the radius and the center. Unfortunately, it's in standard form for it. Well, not circle standard form. We got to get it there. I guess we could call it quadratic form. But find the center and radius of this circle. It's not 0, so don't worry about that one. So here's what I'm going to do is first, I'm going to use the principle of equality. I don't want that -7 there. So I'm going to move it to the other side. So I would say, let's go ahead and just add 7 to both sides. So now this equals 7, which is what I would like. The reason I want to do that is because I'm going to be completing the square for both the x's and the y's, and the -7 isn't really going to help me with that.
That's what I thought you were doing.
So yeah, let's get rid of that 7 right there.
Don't make me do it on this time.
Okay, so I'm going to take my x's and I'm going to separate those over here. By the way, sometimes they'll kind of mix these, right? So sometimes they'll say x squared plus y squared plus 9x minus 10y over here. Make sure when you're completing the square that you have your x's together and then your y's together separately. They're together separately. Sorry if that sounds bad, but I'm going to take the y's and separate these as well. And you'll notice that I've given my space between the x's and the y's so that I can complete the square. But I know that whatever I do to one side, I'm going to have to do to the other side as well, right? So I can't just say I'm going to add this value and just leave it like that. No, it's a principle of equality to balance out this equation. I'm going to have to zero it out by, if I add 1 to one side, I got to add it to the other side. So we know, going back, what do we add to this? Well, remember, you're going to add, it's the b value divided by 2, and then we square that. The b in this case is 9. So that would be, well, it's a 4.5, math nerd. All right, now if I do that to one side, like I said before, I got to do the other side. So I'm going to put that over here. I'm not going to evaluate it yet. We'll get there. But I got that on the right side as well. Now, from what we remember, hopefully, is that this creates a perfect square trinomial. First, right here for the x's, squared. So there I would have x. Thank goodness, by the way, the coefficient of x squared is 1, because I can just complete the square pretty quickly here. But 9 divided by 2 would be positive 4.5. You're welcome to keep the fraction there if you'd like, but 4.5 is fine for me. Well, do you guys want the decimal or the fraction? All right, now that's my x's, but then I've got to deal with my y's as well. So onwards to the y's. Now the y's, same idea. I'm going to have to add the b value divided by 2. It's a different b value because I'm looking at my y's though, and this one is a negative 10. But again, just like we saw with the x's, if I do it to one side, I must do it to the other side as well. So I'm going to have to add that on this side as well. I'll put that in the calculator once I want to evaluate it, but I'm not quite there yet because I've got to evaluate, or now that we've completed the square for my y's, now I can actually simplify it. So negative 10 divided by 2, yeah, that'd be negative 5 right there, right? So remember, we're looking at y's right here. But since negative 10 divided by 2 is negative 5, I know it's right there. And yeah, negative 10 divided by 2 squared is 25. So that's easy enough, but the 9 over 2 squared thing is going to be a little different. Well, let's take a look. Before I get to that right side, I've got two binomials squared, right? I've got x plus 4.5 squared, and then I've got y minus 5 squared. Remember, in that format, it needs to be addition between, which we have. And then this would equal whatever I have on the right side. So let's see what we get. 25 plus 9 over 2. Wait a minute. Oh, it's rather large. But my radius is showing, or radius squared rather, is 513.25. I'm using the decimal. Now that's not the radius. That's the radius squared. So everything else in this equation is good. Apologies. This is where we got to check because 513 seemed a little large to me. I typed it in wrong. I typed times 9 over 2 squared. It's not 513.25. Let's make that addition instead because that is what it should be, plus. All right, so I got instead, I'm not saying it's any prettier, but it's okay, 52.25 instead. Again, that was a calculator error on my part because I typed in a multiply right here instead. Well, glad we caught that. So, we do, as of right now, we do have the center, by the way. We have the ordered pair for the center, which is h and k, right? Or just the x value and y value. The x value there, it's not 4.5 because it's showing addition, but it should be minus, so that'd be a negative 4.5. The 5, however, is being minus, so that's a positive 5 right there. Okay, so again, that becomes a negative 4.5 because it's showing plus, but the operation should always be minus, so it really would be minus negative 4.5, which is what makes that a negative 4.5. The problem right now that I have is I don't necessarily have the radius, but I want it. I would really like the radius. I know you may not, but all I got to do is square root that 52.5. 52.25. So square root in my calculator, 52.25. Enter. Oh, crap. It's really ugly
Yep.
decimal right there.
Square root of that, Mr. Sal? The 52.25?
Okay, yeah, so let me go back there.
Because you want r squared.
Yeah, the original value for r squared, that was 52.25.
That's r squared.
25. That's r squared.
Okay.
But what I want is just r. That's why I've square rooted that. So, but when I do, I get a really ugly decimal. My calculator shows me 7.228416147. Now that would just be the radius. It didn't give us units, so I can't label it in inches, centimeters, or anything like that. It didn't tell me where to round either, so I'm just going to round to the nearest hundredth, which would make this 7.23, approximately. So I'll stick with that. I mean, I'll show both, but either one of those works. Now we have all the answers that we need and all the answers that make us happy inside either one of these. Center and radius, we found it. Same idea here. It's just that last problem, it would have been minus 4. Then we would have had to add 4 both sides, but this one's already there for us. That's great. And they've given us a graph graph. But what we don't have right here, right now we do not have the radius and we do not have the center, which is what we do need in order to graph this. So, to complete that square, let's go ahead and give ourselves some space with the x's. Put them over here. And I guess you could even just kind of do one at a time if you wanted to. And then the y's. And then this would equal 4 right there. I've given myself a little space to add to that 4. We'll see what it is, though. All right, so same idea on that last one. Let's start with the x's. So with my x's, again, I'm going to have to add, it's just the b value divided by 2 squared. And if I do it to one side, I'll make sure to do it to the other side. But my b value for this one is -2. So there, I added that. I put that in, right? I put it in. You can't just put something in without having some kind of reciprocation there. So if you do it to one side, I'm just going to make sure that I do it to the other side. There it is. Now, of course, -2 divided by 2 is -1, and then squaring that, I don't really care. For the right side, we'll get to that. But on the left side, the x's, I now have a perfect square trinomial, even though I haven't evaluated that -2/2 squared, because I'm dealing with my x's. Again, I just look at -2 divided by 2, which would be -1. And that right there is, well, it's at least my h value to start with. What I need then is my y's to also add the b value for the y's divided by 2 and square that. Well, that b value is -4. So let's backtrack to that x squared minus 2x plus -2/2 squared. And if I were to show that, it would have evaluated that -2/2 squared. Then you'd have x squared minus 2x, and then you'd have plus 1. And then the two factors of -1 and -1 right there. So since it's a leading coefficient of 1, you would have had these two binomials. Sorry, it's kind of small, but it would have been x minus 1 and x minus 1. But we're just showing it as x minus 1 squared. To me, that's the nice thing about the completing of the square. Whatever's on the inside of this parentheses, the squaring part is just, it's only being applied to the right side. But the inside, that's what we end up either adding or subtracting to the x's, depending on the sign of whatever's on the inside. This one was negative. So this one as well for the y's, right? This one for my y's, it's going to be y minus something squared. Well, it'd be y. I should start with that. I jumped ahead. But inside that parentheses, -4 divided by 2 is -2. So we just put a -2 right there. Don't stop there, by the way. Not on my behalf. I was just kind of jumping to that conclusion. Don't forget to tack on this.
+1.
Yeah, plus. Yeah, it ends up being, well,
Well, I'm sorry.
that
that's
part
+4.
right there. Yeah.
The first one is the +1.
Yeah, that's correct.
+4.
So I'm just going to put this in the calculator just like we did before. So I mean 4 plus 1 plus 4. I got a 9er on that.
Makes it pretty.
Yeah, that 9's going to make that very nice. I now have enough information to find the center, which is just the h and k. It's the x value. This is x minus 1, so that's a +1 h value. And then the k value, since that's y minus 2, again, it makes that k positive. It's just the regular k right there, too. Just bring it down. But also, we have the radius, which is great news. Now, that 9, it would have been the radius squared, so we would square root these. And so the final radius just ends up being a 3. The diameter is 6. I don't really care that it is, but it is.
It's irrelevant.
Now, from this, though, let's find my center. I'll try to do this one right. So it's from the origin, it's to the right one, and then up to, that's my center at 1, 2. But then I got my radius at 3, so I just need to go in 3 in all directions from that one. So I'm going to start the left 1, 2, 3. To the left gives me this point, -2, 2. Then I'll go down 1, 2, 3. That's at 1, -1. And then to the right 3, 1, 2, 3, 4, 2. And then up 3, 1, 2, 3, at 1, 5. So I'll use the technology second this time because my drawing abilities, anyways. Here we go. Yeah, just little bits at a time. And it's not too bad for me, especially on an iPad. This one. There it is. Hey, it's kind of fuzzy, kind of crappy. It's not too bad for me. Well, the technology was off a little bit, but that's actually my fault. I'll take responsibility for that. All right, write the equation of the circle centered at 10.6 that passes through 13.5. This is great news because right here, it's already given us h and k. We got h and k right there. So for my
And is that our H?
Equation.
Because that's where the center is?
okay, so for my equation, I have the h and k ready to rock and roll. So I got x minus the h squared plus y minus the k squared. We'll get to the radius. We'll get there, but let's put this stuff in first. So the h is 10, and then the k is 6. I don't have to worry about changing these to plus signs. If any of those were negatives, though, I would change that to plus, but I don't have to worry about that. What I need is the radius, and it says that the equation of the circle centered at 10.6 passes through the point 13.5. Okay, well, we're gonna find the radius here, and what I'm gonna do is I'm gonna use the distance formula because that will tell me the distance between the center and this point. That will be my radius.
I'm sorry, repeat that, please?
So the distance between the center, which was given us as 10.6, the radius is the distance between the center and the point that was given. So the radius in this case is the distance between the 2 points. So the distance formula, which we probably don't remember because it was a little while ago, is actually the Pythagorean theorem, if you care.
T equals R.
Well, it's a...
Well, that's not perfect.
No, I like it. I like to see it as leg squared plus leg squared equals the hypotenuse squared, but it doesn't really matter. Okay, but this is my distance between the 2 points, and it's subtraction between those. So I'm going to start with my x's. Let's see, I've got, I'll start with the hk, the center, so that x value is 10 and the y value is 6. And then the other ordered pair, I'm doing blue there, so that's x value that's 13, so it'd be 10 minus 13 squared. And then my y value is 5, so that has to go here. Now you could put this directly into the calculator, but I see these ones that actually aren't too bad to evaluate, even if we're going to square them. But 10 minus 13 would be -3, 6 minus 5 is 1, and I end up with the square root of, really it'd be 9 plus 1, which is the square root of 10. And that is the actual distance between these two. It wants the full equation. This right here, the 10 that I just found right there, that is my radius, meaning that this is going to be the radius, which is the square root of 10, but that also needs to be squared right there. And the square root of 10 squared, well, that's just 10. And now we have the equation.
I'm confused why you put the 10.
So this radius, when we were finding this distance, that's the distance between these 2 points right here. That is the radius, right? So when we solved it and we got the square root of 10, that's the actual distance between the 2 points, which is the radius. Up here, though, it's radius squared in the equation, so we actually do have to square that to get that 10 right there.